Yeah, thank you everyone for the great talks, and also thanks for all the attendees. Some of you stay up in the midnight, and but I hope everyone has enjoyed the workshop today. We have seen a lot of results for discussions. So at the end, we will have a kind of panel discussion like what we had last year. So last year's panel discussion was very well received. So this year we want to keep this tradition, and we want to encourage some live discussion between the speakers and also the attendees. So before we start the panel discussion, so I can share my screen, and I would like to remind all of us the themes of our workshop. So I think now you can pop your questions in the chat box, so the host organizers can collect the questions from the chat box. Because we were intending to have the generic questions in Slack, but it seems that Slack is quite quiet now because I think everyone is paying attention to the talks, very impressive talks here. So now I think it's time to collect some generic questions to all the speakers. So we have 3 themes for our workshop. The first one is hardware focused. So we have development of tactile sensors for perception, action tasks. And the second one, we have multimodal robot perception and action using vision and tactile sensing. The third one, so it's more on human tactile sense, and also how to combine tactile sense with vision. So we have inspirations from how humans integrate visual and tactile information for perception, action, tasks. So today we have seen a lot of talks on these 3 themes. So we have seen these tactile sensors, digits, gel set, tack tape, gel tape. So we have seen these different tactile sensors. And we also see a lot of examples how to use tactile sensors to perform these perception action tasks. So I believe these people who work on the exams will feedback to the people who work on tactile sensors. So any questions in the chat box? Let me have a look.
Okay, so since there's no errors, people are still typing, I would like to ask my first question. So most of you guys have been working in tactile sensing for years, and some of you are working more in the field in recent years. So what's, in your opinion, what are the major differences in the field of using tactile sensing or tactile sensing with vision in the recent years? And what do you foresee for the development of the field in the following several years?
Who would like to go first?
Maybe I can just put forward what I have in my mind. I mean, maybe a very straightforward observation. Neural networks, artificial intelligence seems to conquer all areas, and in robotics as well. And that applies also to force and tactile sensing. So that is definitely a change to a few years back when I started looking into tactile sensing and force sensing. And maybe it's a good thing. So although I have not come to a final conclusion on that for myself, definitely there seems to be a trend to say, okay, we have here a new type of sensor. It can do something clever, but maybe it doesn't give me exactly what I want, or I don't understand really the raw data that comes out of it. So what I do, I take a neural network and it will fix the job. I just go through a very lengthy learning process, and then I have fantastic results. So that's my observation.
Maybe I can say a couple of words about this. I think it's a very interesting question. Something that I would like to see in the years to come is maybe a standardization of the field, in the same way that if I think about sort of touch sensing, the things that the most close similarity is, I guess, vision. And in vision, we essentially had this cycle, this historical cycle, where at some point CMOS sensors were, suddenly very cheap, very available to people, and essentially this enabled really the beginning of a community that would not so much focus on the hardware, but would slowly move more towards service. So essentially building, image processing community, building a computer vision community on top, where you would start building layers and layers of services on top of a reliable hardware. And my hope is that really in the next, 10 years, we can essentially do this jump from having a plethora of tactile sensors that try to do, that maybe use different sensors modalities, but eventually we want to standardize it and we want to start using it, I think, more and more for doing robotics in the real world. I think this would be my hope. So the creation of a field of, touch processing.
I think that's a nice hope, but I also think that the situation is much different than for vision, for example. So in vision, we have essentially one data format, essentially, which is an array of pixels with RGB values. But for force sensing, we essentially can have 60 dimensional forces at different locations. We don't necessarily have a 2D array. We might have the sensors distributed on a 3D shape, like the skin from Gordon, for example. And there might be temperature also involved, but not all the hardware will measure all the different modalities. So some only measure normal forces, some can measure shear forces. So it's much more difficult here to unify or find a common data format for this hope, or to fulfill this hope.
Yeah, I wanted to maybe point on that. Go ahead. It also, I agree that there's, of course, a much more variety of the kind of sensor types or the data types we're getting, but I'm actually pretty hopeful that deep learning will be able to make really big progress on, let's say, the low-level interpretation of these data types, right? So I think actually that the signals compared to the signals that we have in images are somewhat even more structured, right? If you think about the space of all RGB images versus these kind of sensor tactile feedback, I think that there is with network structures that take advantage, for example, of the 3D nature of that data and the temporal nature of that data, that I think we can make very good progress. The question is, what kind of supervision do we need in order to make that progress, right? And then I think one additional question will be, if we can learn good models, let's say for the reasonably low-level sensor interpretation, what comes on top of that, right? Do we, right now also, as we saw, and I agree with Alberto's work, where you then say on top of that, you typically use explicit model-based reasoning to do your controls, but maybe we can even go beyond that then and do more learning also on the higher level control, especially when you want to bring in visual feedback as well.
I wanted to maybe contribute another point there. I think that I agree with something that Dieter said during his talk. I think that on the tactile domain, we have, I'm excited by the prospects of what we can inherit or exploit from the development on contrastive learning or representation learning for tactile feedback. I think that learning policies, one of the things that we've seen, I think that lots of people have seen, is that tactile feedback can be difficult to interpret and can be very high dimensional. So learning policies, I think that require extracting more compact and useful representations, and I think that we need development there. But I think that I'm a bit less hopeful on the amount of progress we can get on complete systems because of the tight interdependence that tactile feedback has with hardware, right? So we've seen over the decades lots of development on tactile sensing technologies, and maybe going into actual tactile sensors, and maybe gradually moving into tactile fingers. But I think that we still have a long road to go through to develop tactile hands that have well integrated tactile sensors where the sensors are in the right place and provide the right information for the way we're controlling those hands. I think that until we have a well-integrated piece of hardware that incorporates all of that, it's going to ultimately limit the amount of progress we can make in this field.
Sorry.
I mean, to pick up on Roberto's point about, for the field to progress, you need accessible and available tactile sensors for everybody to use. I mean, for a long time, it's basically just a BiTac. You could buy, if you got a large grant where you could buy $10,000 per BiTac. And what's really changed in the last year or two is for optical tactile sensors, the cameras are now available at really small sizes, like a millimeter, a couple of millimeters in size. And that's what has fundamentally driven Roberto's work, also some of our work where we've got a fingertip-sized optical tactile sensor as well. And it's because of that hardware availability in combination with the 3D printing, so that people can buy these cameras that are very small, can fit in the size of a fingertip, and then make the physical structure of the tactile sensor themselves. That in principle can open up the field.
Yeah, I would like to follow on this discussion. So we have seen one interesting question in the chat box. So what have panelists heard from people who are not using tactile sensing and doing manipulation? So for example, if we go to SACV, CVPR, definitely there are people who are working on manipulation without tactile sensing, only with vision. So for these people, why aren't they using tactile sensing? Is that because the tactile sensors are not available to them, or any other reasons? And what we can do to make a greater impact later? Yeah,
maybe I can speak a bit to that, because we're doing work exactly in this intersection with manipulation and computer vision. Well, on the one hand side, of course, it is also related to that it's not so easy to get your hands on good tactile sensors these days, right? That are also well integrated. And at the same time, I think it's also just that the pre-tactile phase of manipulation is still such a hard problem from the perception and reasoning side that people feel like they are being kept busy just by that problem, right? Like, how do you pick up an unknown object? How do you move it to a certain location? How do you do things with these objects? So the perception challenges, even without touch, are extremely hard. I hope that over time, as we get, for example, like Roberto's sensors, or also the sensors that Roberto has been developing, as they become more available, hopefully it will become also more mainstream, that people, for example, from the computer vision community will start working with them.
So follow-up question to Dieter. So do you think by introducing tactile sensor, it's possible to make the perception problem easier, or it's kind of harder? Like we can probably have more information, but like overall, the framework will be more complicated. What do you think?
Well, again, I think until you make contact, as far as I understand it, at least, touch sensing doesn't really help you a lot, right? So the huge space of what you do before you even touch that object is still something that you have to solve, right? Like how do you reason from where to approach an object and all these kind of things. I think touch sensing is clearly going to help in all these kind of tasks. Like once you make this contact, right? They're going to add robustness. They're going to help, especially with vision doesn't help you anymore when your hand is occluding most of the object, right? If you can't see it, then purely based on vision, you can't do anything with this. This is where touch is going to be really important. Fine-grained tasks, in-hand manipulation. So I think touch is going to be really crucial moving forward. One question is, of course, is it just like learning a joint embedding of vision and touch? Is it sufficient to learn good touch embeddings and vision embeddings and then do some kind of late fusion later on? I think how to combine these in a nice, consistent way is still kind of an open problem at this point.
We have another question, I think mostly for Gordon. The question is, I would like to ask about your insights about large-scale tactile skins. What do you think is the optimal representation of tactile signals, considering the limitation of embedded systems, and for reactive control, considering essentially now the raw tactile data are mostly 2D? Okay, so it's a very interesting question. And I remember last year we did discuss the types of different tactile sensors and also representing the tactile data in 2D and 3D. Gordon, are you?
Yeah, I'm not sure if I fully understand the question. What we were focusing on is a 3D reconstruction of the surface. And that gives you self-localization of every single point on the contact point. And at the same time, because we are focusing on multimodality, when you know the location of the contact, then you know all the different modality you're making contact with, you know, temperature, vibration, and forces. So I think that was one of the earliest work we ever did that we felt it was very significant. Localization of the actual contact point. And the difficulty with most of the older work is the manual calibration. And if you do large surfaces, it's almost impossible or really, really painful to actually calibrate any of these spatially. And the earlier work of Nemelsky, that was a massive amount of computing that he had to use. He was using massively parallel computing just to actually deal with the robot arm. So that's also one of the issues that we had to solve. That's why we are now pushing towards autonomy. So the techno system that we have now is just almost plug and play. You know, and you can plug it into any system without adding another computer. And I think that's going to be critical. And I agree with Roberto and all the, also Nathan about this. Availability is going to be the biggest contribution to the community to push the whole field forward. We hope we can do that. Caspar asked a very good question earlier today, how much? I think we can hit the target. We will hit the target to get the price down and make it available to everybody.
When will it be available?
You're recording this, so I cannot say. Okay, can I tell you offline?
Okay, yep, sure, please
Thank
do.
you.
So in the previous questions, we have talked a lot on the tactile sensors, the hardware. So the next question is more on the tasks, what we can do with tactile sensors. So it shows the community focus on manipulation tasks or abilities of tactile sensing like precision, dynamic range. We are working on tactile perception. I think the main question is what we can do with tactile sensors, like beyond tactile perception.
I think that some of the speakers already sort of hinted at this quite explicitly. There are two aspects of touch that I think are interesting. One aspect is, of course, the perceptual side, determining properties of object, trying to understand the world better. But eventually, the part that I think that as a roboticians we care more about is instead closing the loop for control. Being able to use touch for having better grasp, having touch for controlling better in hand manipulation. These are the things that really I think are important beyond just pure perception.
Well, I think there's a grand challenge for the community, for the field, which is basically anything that humans can do, and then to go as far past humans as is possible. You know, our sense of touch is limited. We have long latencies, not necessarily that accurate in some aspects of touch. You know, there's no reason why robot touch can't be far superior to our sense of touch and give far superior manipulation and dexterity in robots than humans can do. When that will happen is another question, but you know, it's an engineering challenge, if you like.
Yeah, totally agree. Yeah. Actually, I would like to hear Vincent's idea on this question, because Vincent has worked on a lot on the human touch. So I would like to hear his idea, what we can do beyond what we have done so far. Vincent, are you here? Okay, it seems he lost the connection. And also, there's another question on hardware. So, what are some of the integrated tactile sensors do researchers here use? Only off-the-shelf, a reliable sensor I have found is the single tact sensors from pressure profile. So, to make a greater impact, so can we set up some guidelines? What sensor we can offer?
So I think currently all the labs are still experimenting a lot with different technologies, and we are far away from really commercializing those new technologies. So I'm really curious to see maybe this digit sensor from Facebook to become commercialized. Not only open source, but still a lot of effort to really replicate this stuff. But yeah, that's, I think, still a way to go, as Nathan just said.
Yeah.
Yeah,
yep.
Personally, I would love to see digit commercialized, but well, it's not up to me.
Yeah, I hope we will see this day coming soon. And as we can see, for probably for the vision community, so like the RGB cameras are widely used, and it can make the community strive. And if we make the sensors more commercially available and also available to more researchers, so maybe it will help us to make our community strive.
I think an issue with the commercialization is that for it to work, a company has to make money off it. And, you know, all the sensors we're talking about today, I mean, for example, Roberto's, Shan's, mine, we've papers on it, we haven't patented it, it's all out there publicly available. So, you know, it's not the kind. It's difficult to get a company to work off the back of that. You need to protect it first. I don't know if anybody else has a comment on that.
But I think having a low-cost sensor available will give the community a huge boost. So think back at the Kinect when it became available, the depth sensing and yeah, whole 3D perception got a real boost, and everything got so much easier than that time. And I think we do need some similar breakthrough through commercialization of a low-cost sensor in the tactile domain as well. I can only encourage Facebook to really push that. I cannot imagine any other reason why Facebook doing tactile research.
Yeah, so Roberto, you heard that you're the richest people here, so we all expect you to ask Facebook to help the community.
I'll do my best. Yeah. But I agree. I think that it would be great to have any low-cost sensor that people can just buy, and and buy tens of them, and if some break, just replace it. I would love that.
Roberto, can you comment on the motivations of Facebook doing this kind of research?
Oh yeah, absolutely. I can make a pitch. So I'm in Facebook AI research. So the motivation for doing generally research in robotics is because we are interested in studying how AI can essentially benefit from embodied intelligence. Arguably the only intelligent system we know are physical systems like humans and animals. So applying AI to robots has a number of challenges, like being able to be robust, being able to really run on on physical hardware, being that efficient, and these are all things for which robotics seems to be a perfect application for developing new algorithms. And touch sensing is because I love touch sensing. I think it's a great thing, and for sort of doing my own research, this was a necessary step.
Thanks.
Yeah, totally makes sense. Yeah, and also like Robert mentioned in his talk, so like OpenAI, they have because they have a lot great algorithms in simulations, like reinforcement learning algorithms in simulation, and now they are also moving to this physical hardware. So how to manipulate the cube, and you can see people are paying attention to these physical systems. And I hope this will make our community grow in the coming years. Okay, any other questions?
Well, I'd like to ask Robert, since he has been in this community for very long, what is the most challenging task that we should be focusing in 10 years from now?
Regarding tactile-based manipulation, you mean?
Yep.
So I think all kinds of in-hand manipulation tasks will be quite challenging, where you might need to combine both vision and tactile, of course. That's the basic idea of this workshop. But I think maybe we can even mainly separate these two concerns, because as Dieter said before, vision is mainly for kind of long distance perception, and tactile comes into play if you are in contact with the object. And if you are doing in-hand manipulation like this, then you are already in contact, and you can do that blindly. You don't need really the vision. But yeah, getting the dexterity of the hands, I guess we already have them, and yeah, developing the algorithms to make sense of the sensing and really apply the corresponding motion control signals, that's the challenge for the next years.
Actually, there's a question in the chat box. Actually, I would like to ask before. So the question is, don't we need a task like computer vision had with ImageNet for pushing the fields? So like Nathan mentioned before, maybe if we have a challenge for the fields, it may push the fields grow faster. How do you think? So for example, we have this object set, and we have a common robotic setup, and we have all of the great tactile sensors, what we have heard today, and we set up one challenge.
I think it's much more complicated than in vision, because the standard vision task, of course, is object detection. But what is the standard manipulation task? So manipulation is so much more diverse that it's not easy to come up with some default tasks. I think getting these data sets for tactile perception of different materials is already pushing along that direction in certain fields, of course. And as soon as we see other data sets becoming available for different types of manipulation tasks, we will also see progress there.
Can I comment? Can you hear me? Yep.
Yeah.
Okay. Just wanted to add that, and this goes back to the initial point, that before we can have something like that, we need standardization to happen, because what you learn in ImageNet can be reused on any camera roughly, but what you learn from even from two different biotags cannot be replicated. This is what we heard today, right? So before we can actually get something like an ImageNet for tactile sensing, we need to be able to have standardized sensors or whatever that can be replicated. And calibration, I think, is the key technology for that. To have some mechanism for calibrating sensors so that the data you get out of the calibrated sensor is portable, is comparable across different devices. A bit like what happens with images after you do the calibration and rectification, you kind of have an image that can be reused. And it doesn't matter so much if it is acquired, it's been acquired from one camera or from another.
Kind of hard to define standardized tasks in touch. I mean, I'm sure all of us have had in papers that we pick the task that we like doing, and then a reviewer goes, why didn't you use that benchmark task? And it's like, well, actually, because I thought the task that I thought up was better for the scenario I was doing. And so you kind of need this sweet spot where the task is kind of achievable and doable, but it's also interesting and kind of inspires people, that people actually want to try and do that task themselves. And I don't know, maybe it needs the field to advance a bit more in capabilities first before we start hitting some really interesting tasks that everybody agrees are in, you know, are kind of good to do and interesting as well. I don't know.
Yeah, maybe we can have the community grow for some years, and we standardize these tactile sensors, and then we set up the challenge afterwards.
Once we start getting some tasks that are really human-like in capabilities, but that everybody can do easily with the hardware and the computational capabilities they've got, then, you know, the tasks get more interesting and people would maybe want to compare them.
Yeah. Okay, I think it will be pretty much for our workshop if we don't have any further questions to the panel. So I think we can thank our speakers again. thank you very much for your great talk. So unfortunately, we can't go to a pub like last year. So sometimes if we go to a pub after workshop, we can all foster better discussions. But we hope we can have such discussions in the pub next year. Okay. And also for
thank you also. Thank you very much to the organizers, and in particular to Shan for organizing such a fantastic workshop. Thank you very much.
Thank you.
Thank you. Thank you very much.
Thank you.
Thank you.